Thank you, comrades. The question of how human beings came into existence and how we developed is one of the most important and greatest of all scientific questions, and there can't be any people anywhere in history who've not wondered about that question. It's an obvious question. Where did we come from? How did our species arise? And is a proper subject for serious scientific inquiry. And for most of human history, the answers to that question, in one way or another, have been bound up with religion and myth. All sorts of different forms, but it appeals to different origin stories, different mythologies, different religions, to try and explain different creation myths and so on. You can take your pick from history and around the world which particular one you might have hung on to. And it's only quite recently, in the last 150 years, that that's been replaced by a serious attempt to give a scientific materialist account. And the starting point for that 150 years ago obviously is the publication in 1859 of Charles Darwin's On the Origin of Species. Darwin wasn't the first person to suggest that human beings had arisen through a process of biological evolution. Other people had suggested that beforehand. His grandfather, Erasmus Darwin, had already done that. What Darwin did, and somebody else called Wallace, who was working at the same time, was to try and give a scientific explanation of how that process of evolution had actually taken place. And I want to spend a few minutes just to underline what Darwin actually argued, because his argument for what evolution is and the process that took place is often misunderstood. Because Darwin's argument was that evolution had taken place through what he called a process of natural selection. And it's important we understand what he meant by that. The first thing is that Darwin looked at the simple fact that the offspring in any species resemble their parents, to use human language, that they look the same, they have many characteristics the same. But it wasn't simply that there was also variation. That if you to put it in human terms, that children look like their parents, but they're not the same as their parents, and there is variation among the offspring. The observation of that fact in all species was Darwin's starting point. I'll stress now that Darwin did not have the slightest idea about why that took place. What we know today about the genetic basis for that was not known at the time. Darwin simply observed the fact of the inheritance of characteristics and the variation. But he started from that observation was the basis of what he said. And then what Darwin argued was that, and he based this on huge amounts of observation, was that that variation meant that in particular environments, some individuals who were the offspring would then have a greater chance themselves of going on to successfully reproduce. And that was the key argument. And it was that differential success in reproduction which over time could, and I underline the word could, then lead to the evolution of new species. Some individuals would have a better chance of reproducing because they had certain characteristics, and over time those characteristics could then spread and lead to an evolution of new species. And that theory of natural selection, evolution by natural selection, has, I would argue, become established beyond any serious doubt over the last 150 years as the basis for understanding how species have evolved and changed, including our own species. When I say it's been established beyond doubt, we shouldn't be complacent though. In the US, for example, about 40% of the population reject that, think it's not true, and believe in some form of creationism, that God still created all of the species. So we shouldn't be complacent about this. There is still an argument about this, largely coming from the right and people who have religious ideas. But we have to absolutely defend Darwin's account. As I say, he didn't know anything about the genetic basis for that, and I'm not going to go largely into that today. Now we do understand how some of this process takes place. There are lots of arguments about exactly how it takes place. Anybody who's read some of the debates, I'll use names to illustrate different positions. The arguments put forward by people like Richard Dawkins in The Selfish Gene, The Blind Watchmaker, and a whole number of other books on the one hand, and some of the arguments put forward by people like Stephen Rose, Stephen Jay Gould on the other. There are serious and legitimate arguments about the exact mechanism. Does natural selection only operate at the level of individual genes? Does it operate at the level of species, and so on? Exactly how does it work? I haven't got time to go into that today, but those are real arguments that people should read. One important argument, however, is the question of how species arise, because just because you have variation, just because you have differential success in reproduction, it's still the case that by and large any changes that come will then be reabsorbed back into the population. They won't be sustained through time. And that's why when you look at the fossil record and look today, most species are stable through time. You have species that persist for millions of years. The variation goes on, there are changes, but the population reabsorbs us because those individuals then interbreed with other individuals and so on. I mean, people who know something about this, there's what's called regression to the mean, that things tend to converge back to where there's a stability in the process. It's not automatic that variation, that natural selection, that differential success in reproduction then leads to the emergence of separate species. And again, there are debates about how that process takes place. I would say there is reasonably convincing evidence, but again I'm cautious, we don't know all these things for certain, that what's sometimes used in technical jargon called allopatric speciation. And what that means is that for different reasons to do with the environment and whatever, that sections of a population can become separated off, isolated, through changes in the environment, for example, and that allows variation within that subgroup to then be consolidated and lead to the emergence of a new species. I'll give one simple example, not about humans. If you take our two closest relatives, the chimpanzee and the bonobo, both apes, they are separated physically by the Congo River in Africa. Genetically, they're virtually identical, and they're our two closest relatives. But that physical separation has led to the emergence of two quite distinct species, which actually have very, very different social behaviour and so on like that. Again, I haven't got time to go into it, but anybody who says, we can derive our behaviour from chimpanzees, well, all I would say to them, they're our closest relatives, but we're just as close to bonobos. Look at their behaviour and you'll find two totally different things, so don't overgeneralise from that. But the point I'm making is the physical separation by environmental things is often a key factor in allowing that variation to then be consolidated into the emergence of new species. It's not an automatic process without that. Let me give an illustration, because sometimes people say, well, how does that work? And so I'm a maths teacher, so sorry to Sunday morning at 10 o'clock to indulge in some maths, but I think it's important to understand this. So let me give an example. Suppose for every 100 individuals who have a particular variation, they survive and successfully breed, but only 99 of those who don't have that variation themselves survive and breed. A tiny difference, one in 100, not very big at all. If you assume that it takes 16 years to get to the point where you breed and reproduce, then what that means, if you do the maths, is that in 70 generations, 1,000 years, that tiny difference means those individuals who did have the variation will then be twice as likely to successfully breed as those who didn't. Now that's over 1,000 years. When we talk about evolution, we're talking about processes over 1 million years. So tiny differences can lead to very rapid changes on an evolutionary timescale. So sometimes people think, well, how does this happen? I just wanted to get that clear. But what about human evolution? Initially, Darwin didn't talk about human evolution. He was fearful of all sorts of reaction from the society he lived in, the Victorian society and so on. And it wasn't until 1871 that he published his book on the descent of man, and he used the word man, which again is a sign of the times, and he gave a detailed attempt to apply his theory to human evolution. I'm not going to go into the details of that. Actually, I would say to people shouldn't be put off. If you read Darwin, any of his books, the one thing Darwin did always was he wrote very well for a non-specialist audience. Anybody who's ever read, for example, The Origin of Species, it's not a difficult book to read. You can read it, it's really well written. As he says himself, it's one long argument. And that's Darwin writes in that spirit. So anybody who wants to get into the details of these arguments, go and read Darwin. You don't have to have a biology degree to understand it. It's written in a really accessible way. So go and read it. What I want to focus on was an argument between the position that Darwin advocated about human evolution and a position that Friedrich Engels, Karl Marx's collaborator, articulated in the 1870s as well. And Engels followed all of these debates really closely and was really engaged with scientific debates. And he wrote a book called called The Part Played by Labour in the Transition from ape to man. To understand the argument, you have to understand what are the key changes that define human beings as opposed to our ape ancestors. And so it is worth stressing, we did not descend from chimpanzees, gorillas, etc. All of us share a common ancestor, and that's a very different proposition. It's not that, there was chimpanzees and then there were humans. Chimpanzees themselves are descendants of a shared ancestor that all of us have way back millions of years ago. But there are three key characteristics. If you look what are the changes that define us as a species. The first one is what's called bipedalism, the fact that we walk on two legs, as opposed, if you've ever seen apes walk, they do walk, stand up on two legs sometimes, but they also walk, use their hands to walk. They're not exclusively bipedal. Human beings are. That's the defining characteristic of human beings. The second thing we have is we have what's called an opposable thumb. The fact that we can grip things in a particular way. We can use our thumb, if you like, and touch it to the end of your fingers. We're the only species that can do that, by the way. It might seem a small thing. It's extremely important in terms of our ability to manipulate the environment. So we're bipedal, we have an opposable thumb, and the other thing is we have a very big brain relative to any other species. We have a huge. So those are the three characteristics that define us as opposed to any of our ancestor species: bipedalism, an opposable thumb, and a big brain. Darwin argued, in essence, and I'm oversimplifying, that the big brain came first. That we must have evolved a big brain, and all of these other things, bipedalism, the opposable thumb, and everything else about humans came afterwards. Now, Darwin had reasons for arguing that, but you can see how that fits very well with a Victorian gentleman with a certain position in class society, that, you know, the intellect, the brain came first, and things that might have to do with manual labour come further down the line. That's a bit unfair to Darwin. He didn't simply have prejudice, but you can see how the view that he came to fitted with a certain position in society. Engels argued a very different view. He argued, no, bipedalism came first, because that allowed human beings then standing up, and it was then the freeing of the hands then to engage in labour, and the need for that labour to be cooperative led to the co-evolution of the opposable thumb and the big brain. But the bipedalism, the change, came first. So a very, very different view. Now, the truth is, neither Darwin nor Engels had any bloody evidence at all for this, because there was the first fossils of our ancestors were only just being discovered at the time that they were writing. At that time, nobody had any serious evidence. So it was an argument about what took place. What Darwin's view shaped most of thinking about evolution for a very long time. So, for example, in the 1920s, when people started in southern Africa discovering fossil skeletons of what's now called Australopithecus, one of our ancestors, that was disputed that could be part of our evolution, because they were bipedal, but they had a very small brain and didn't have an opposable thumb, so it didn't fit with that view that Darwin had, so people didn't like it and challenged that. One of the great hoaxes of the 20th century, Piltdown Man, which people will heard of, which was actually a hoax probably perpetrated by a Catholic priest called Teilhard de Chardin, where they stuck together bits of old fossils, but it was to create a so-called missing link in human evolution. It was found in southern Britain, in Sussex, where it showed somebody with a fossil with a big brain, but not bipedal and so on, and they were still trying to fit into that model of the brain must have come first and everything else afterwards. So this really did influence thinking about human evolution for a very, very, very long time. Most of the scientific establishment, with some exceptions, accepted that general approach right up until the 1960s and 1970s. Actually, what we know now is that it was wrong, and that Engels' basic argument was correct. Now, this doesn't mean Engels was some great expert. He had certain instincts and so on, but it's important that Engels' argument was essentially correct. That we now know that bipedalism came first, and not just by a little bit, by a very, very long time. It was the crucial step in all of human evolution. So let me try and sketch out, and it will only be a sketch of what we now actually know about human evolution. But first, a word of warning. All of these arguments and all of these theories are based upon very little evidence. All of the fossils we've got, fragments of bones and so on, of the whole of human evolution would probably fit in a box about the size of this table. It's not a lot. We've got a few bits of fragments and things like that, so we need to be cautious about. We can think some things are true, we can say there's some evidence for certain things being true, but we should be cautious enough to admit that there's lots of things we simply don't know. But we can have a fairly reasonable view of the broad process. We also need to guard very heavily against what's sometimes called just so stories. It's derived from books by Rudyard Kipling, which say that, we have this physical characteristic today, or this form of behaviour today, so I know, let's go back and invent some scenario that might have been true millions of years ago in the past that could possibly explain how we evolved this. That's not a scientific method. It's nice for children's stories about how the giraffe got its neck and things like that. It's not a serious scientific approach, so we need to avoid that approach. So what do we know? Firstly, as I said before, we did not evolve from chimpanzees. all existing ape species, ourselves, chimpanzees, orangutans, gorillas, etc., are all descended from a common ancestor. Now there's some argument about when that is. Something like 6-7 million years ago seems to be the most likely date, that there was a common ancestor to all surviving apes. The evidence now seems to be that the first step in our evolution was the evolution of a bipedal ape, an ape that began to walk on two legs somewhere in the region of 3-4 million years ago. Again, we don't know precisely this, but it was quite a long time ago. Some people want to push it back even further to 5 or 6 million years, and there's legitimate debate about that because people find fossils, and to be honest, what happens is people find a bit of a bone, this bone here, that's all, and then they look at the way the thickness of that, and on that basis make conjectures about what that tells you about how they walk. Now that's serious science, but let's not pretend it's established beyond any doubt. It's an ongoing scientific inquiry, and there's lots more evidence needs to be get. But there seems to be reasonable evidence that somewhere in the region of 4 or 5 million years ago, you had an ape which didn't have an opposable thumb, which didn't have a significantly bigger brain than other ape species at the live, which did begin to be bipedal, to walk on principally on two legs. There is lots of argument about why that process took place. The most likely explanation is significant environmental changes in Africa, and it's worth stressing, for most of human evolution, all these species existed only in Africa. It's very recent that anything came out of Africa, so most of human evolution took place in Africa. That bipedal ape did not have an opposable thumb and did not have a large brain, and actually it coexisted alongside a whole range of other ape-type species in Africa. Today we're the only species that survive. For most of evolution, there have been lots of different ape species, including ones in our own evolutionary ancestry. It's more like, if you want to have a picture, that famous picture where you have, the one where there are apes like this and slowly they stand up and then eventually you get humans and it's nearly always a man at the end for some reason carrying a briefcase. That's a nonsense picture of evolution. Darwin himself talked about the tree of life, and that picture of a bush with lots of different twigs and branches all coexisting, and some of which then die out and some go on to give rise to further branching. That's much more an accurate picture of what we know about how evolution. It's not a linear process at all, it's a bushy tree-like process, and again that's quite important. So we've got bipedal apes. One of them is known as Australopithecus. Lots of these names are because there's a fashion in British history and scientific history to use Greek and Latin. So Australopithecus just means southern ape. So don't get mystified by the names. It just means an ape that lived in the south because they found it in South Africa, but it's just in a foreign language. So lots of the names sound deliberately obscure, but that's just one of those things we have to live with. So we've got a bipedal ape that survived for a couple of million years, but it simply walked on two legs and coexisted with lots of other apes. The next key thing that we know is that probably the first species we can say is genuinely in our ancestry, again, goes under the grand name of Homo Habilis. Again, that just means handyman. And the reason it's called that is because about 2.5 million years ago, there is then fossil evidence of something that had changed. Bipedal apes that start using tools in a systematic way. And I say systematic because actually chimpanzees, bonobos, etc. do use tools, but they don't use them in the same systematic, organised way as a key part of society. If anybody's seen various TV programmes, you can see apes will use twigs and sticks and fashion them and things like that. There's a difference between that and the systematic, structured use of tools as a core part of how that species survives. And about 2.5 million years or thereabouts, there's evidence that there's a new species arrives, Homo Habilis, which begins to use stone tools in a systematic way. In Eastern Africa, there's lots of evidence of this. And again, that existed alongside other people. It had a marginally smaller brain, but even at this stage, the brain size hadn't accelerated massively. So you had the beginnings of a species that walked on two legs, was beginning to use tools, and was clearly a step towards something different. The key evolution, the first species I would say you could recognise as essentially the big human in that sense is what's called Homo Erectus. And again, you don't have to know much Latin to work out Homo Erectus means upright man, because it's the first one where somebody's fully erect, standing essentially the same way we do, and walk like that, and definitely had a much bigger brain now. The brain size has doubled, and there's definite evidence that they had an opposable thumb and much more sophisticated tool use. Now, we don't know the details of how all of this process took place. We've got very fragmentary evidence, but if you look at the picture, the sequence is quite clear. You first have a bipedal ape without a bigger brain, which doesn't use tools. Then a couple of million years later, you then have an ape with a slightly larger brain, which begins to use some form of tools. And then a lot later on, again, you start to see the increase in brain size, the opposable thumb, and the further development of tools. Now, what Engels argued back then, and what today is now understood, is that once you've got bipedalism, you then get, Engels would have used the word, it was the dialectic of intellect and labor. In other words, it was the interaction, once you have a bipedal ape, of social cooperation to make tool use to survive, and that giving an advantage in survival and reproduction, and not just the tool use, but that in order to operate in that way, you need social cooperation, and therefore the need to have language, rules, negotiate social situations, those two things going together. The interaction, dialectic was the word that Engels used, but once you have a species which walks on two legs, is beginning to use tools, and is beginning to socially cooperate in how to organise itself to use those tools to survive, that creates a situation where the interaction between those can then selectively favour the evolution of larger brains, which give an advantage in social cooperation, language, and tool use. And this is a long drawn out process. Today some people use the words gene culture co-evolution. Now, I don't care what language you use, it's essentially the same thing. That idea that you've got bipedalism and then a process driven by the selective advantage big brains and opposable thumbs give for survival by working together in social cooperation to work on the environment and tool use. It had to give some big advantages because big brains are extremely expensive in biological terms. They use an enormous amount of energy. It's not possible that they were selected for unless they did give a very serious advantage to groups that were able to work in that way in terms of their ability to survive and reproduce. There's lots we don't know about the process, but I think if you look at the evidence now, it's very clear that something like that must have happened, because we know some very material facts. Bipedalism first, then at a much later stage, the beginnings of tool use, and then the process by which you get the development of an opposable thumb, more systematic tool use, and the development of a big brain, which is key for designing and using tools, but also for that process of social cooperation. So some process by which that combination of things gave a selective advantage in allowing people to successfully reproduce must have been the key driving factor in that process. And no doubt over the next 150, 200 years, I hope scientists will be able to find out a lot more about the details of how that process worked. But I think that the broad outline is quite clear. The Homo erectus was the first human species which left Africa, and it spread all over the world, and then there were local variations that evolved from that. In Europe, probably the species some people will have heard about, Neanderthals, was probably a descendant of the original expansion of Homo erectus from Africa. In Indonesia, what's sometimes been called Hobbit man, Homo florensis, on an island in India, which is a much smaller species, probably was also a descendant of Homo erectus. In other words, Homo erectus spread out of Africa and then gave rise, like any species, to all sorts of local adaptations and so on. But then something else happened. And you can argue, this is not precise, about 200,000 years ago or thereabouts, you have to take all these figures with a pinch of salt, for reasons we don't yet know, something new happened, which is in part of Africa, there was a further evolution to essentially our species. There's some evidence it was probably in the area around Namibia, Angola, and again, but that's all still subject to debate, where essentially you get the emergence of fully modern humans. People who, if you washed them and put them in the kind of clothes we were wearing, you wouldn't seriously recognise the difference. They essentially had the same kind of capacities that we have. There's a little bit of evidence that various climatic changes, something called the Toba eruption, and the impact that had on the environment in fragmenting populations around Africa, reducing the size of the existing hominid population, played a key role in that. But again, these things are not firmly established. There's the beginnings of research on that. I think there's very clear evidence that when you get the emergence of fully modern humans there, that they coexisted with other species in Africa for a while. It's not the case that human beings then emerged and we went around and wiped out everybody. This is complete garbage and not the way that things happen. There is some discussion about were those people fully modern. I can see Pete in the audience, we've had debates about this, because it is also clear that for a long time, from 200,000 years ago up until about 60, 70,000 years ago, you didn't see very rapid change in terms of a cultural sense. You didn't see the emergence of art and culture and a rapid development of tools. There was a long period of stability. I would argue that it's not the case that they were static either. There is evidence now from various caves and excavations in bits of southern Africa where you see the beginnings of ritual and art and music and so on, but that's contested and there's still debate about that. I think what there will be agreement on is that there have been no further biological evolution in human beings in that process, that everything that's happened since the emergence of Homo sapiens in Africa about 200,000 years ago is not driven primarily by that Darwinian process of evolution by natural selection, but is principally driven by social and cultural changes. In other words, the social processes that we as Marxists try to engage in. What's undoubtedly true is that around about 70,000 years ago, and you can argue about the precise date, there was the spreading out of Africa of Homo sapiens all across the world, and then quite rapid evolution in terms of the evolution of cultural forms of behaviour, art, ritual and music that we can clearly identify as modern humans. I want to stress that's not a biological change though. That wasn't something that a new species had been selected. It was a change in the cultural and social patterns of behaviour. And why that happened, why people moved out of Africa, again, there's some evidence that significant climate change and things played some role in that. I would argue that's not the only cultural change there's been, because sometimes in these arguments people conflate bits of history. So people talk about, oh, well, that happened 60, 70,000 years ago, and then they talk about the cave paintings that you see in Lascaux and places like that. So actually, that was a different period. Those came much later. That's about 30,000 years ago to about 12,000 years ago. So there have been repeated significant cultural changes in human history. But the key in terms of the evolution of modern humans, I would argue, is that pattern, that about 200,000 years ago, there was from the existing Homo erectus population, a further evolution in Africa to fully modern humans, which then has begun to spread out across the world. There's lots of argument about how did they replace the existing human populations that were already there, and you can read all sorts of lurid accounts about people going to war, killing each other. That's rubbish. You don't need that for species to be replaced. Take the example of red and grey squirrels. They don't fight each other. But in a very few years in Britain, because of a tiny selective advantage for survival that the grey squirrels have had over red squirrels, without any direct competition or so on, largely in most parts of Britain, red squirrels have been replaced by grey squirrels. In other words, natural process of differential survival are quite enough to explain the replacement of one species by another. There is now also quite good evidence that actually Homo sapiens, our species, interbred to at least some degree with the pre-existing Homo erectus, Neanderthals and things like that. There's argument about how much, but I think there's no doubt that there was at least some interaction. So some interaction went on. Now, just to sum up then, that the key arguments about human evolution was that Darwin, his essential theory about how evolution takes place, I think is established beyond doubt, that process of evolution by natural selection is the foundation for a scientific understanding of all evolution. He had a particular view about human evolution which prioritised the development of a big brain, which I think was largely grounded in his position in Victorian class society and what that led to. Engels put a different argument that actually no, it was bipedalism that came first, then the upright walking, the freeing up of the hands, and then the possibility of tool use and social cooperation and language, and that combined package gave a selective advantage, and that then was mutually reinforced, that you had the repeated selection of big brains, opposable thumbs, which made that more possible, and that was the key driving force in our biological evolution. And that about 200,000 years ago, that process led to the emergence of essentially our species in Africa, probably in the southern bit of Africa. And then since then, all the changes in human cultural behaviour, which have been huge. You can talk about the beginnings of art, the beginnings of ritual and music spreading out across the world. We can talk about the transition to sedentary forms of life, the origins of settled societies, and then since then the origins of class society and civilization. All of those changes are not biological processes. Those changes are driven by social, political and cultural factors. There is no fundamental difference between us and the people who lived 60 or 100,000 years ago. What has changed is all those social things. So that's essentially the account that I think is more or less valid. There are lots of details that are still legitimately contested because we simply don't know lots of factors. One thing I will say is that it's foolish to say, oh, Engels was right, that proves how Marxism allows you to solve scientific questions. That's stupid. Engels didn't know lots of these things. What Engels did have, and I think this is an important testament to Engels, is an ability to not start from the kind of prejudices that limited Darwin's ability to analyse things. Engels started from, let's look at the material basis of how these things happen, and let's try and understand how change happens for material scientific reasons, and then look at how that process might unfold. And actually his broad approach has been underpinned and underlined by all that we've found out since, although there are lots of details on which both Darwin and Engels were wrong, and no doubt lots of things I've argued here in 50 years' time will make further discoveries that will change that picture. But the broad outline of that process, that Darwin's theory, but in the way that Engels argued, that bipedalism comes first and then the combined evolution of opposable thumbs, tool use, language, big brains and social cooperation, that's the defining characteristic in our biological evolution. And once we arise, however, it's wrong to see what's changed in human history since then as a biological process. It's driven by social, political processes, and today by class struggle and all those kind of things, not fundamentally by biology, which is why all that nonsense, genetic determinism, evolutionary psychology, is nonsense and is on a par with Rudyard Kipling's Just So stories. And we shouldn't be seduced by that. Does that mean that there are not lots of important and serious debates to have about how the material process of evolution took place? Of course not. There are real debates to have about that. So I'll stop there and we can open it for discussion.
Okay, my name is Jan. I want to thank you for your very interesting lecture. And what I understand is you say it is now no longer, like social Darwinists say and bourgeois thinkers say, that this society is nature and it is a biological evolution and everything like that. And we contest that and we say that it is about history and social factors and also class struggle. But there is one problem. My question is that there is one problem. And nowadays, scientists say that genes and brains are genes. Let's talk about genes. That genes are social. That means that they are influenced by social factors, and that in positive and a negative way. So in that sense, and they have even a new science that they call it epigenetics, and that is about social factors and social influences in the genes. So my question is then that when that is true, that that class struggle and social factors influence the biology influence also the social factors in both in a dialectical sense, and that even for the genes we need class struggle and sex struggle, because poverty is one of the main causes in that process. Not only because of this poverty and you have hungry, and you are hungry and you do not get good food, but also your carers, the educators, the maternal or paternal people are very stressed, and that in the process between the child and the educator, the carer, makes also the child nervous, and it is also bad for the genes of the child. So also, is it so that also on the long term we need a revolution even for the genes and the biology?
Yeah, I wanted to speak to this subject of epigenetics because it's a very interesting area, but I think we have to be careful not to take it too far. So epigenetics is basically this idea, with genetics essentially, where mutations, build up over time, and then you get natural selection acts upon them, and they're actually, obviously a driving force for evolution. Now, Marx said, if a giraffe reaches up to the highest branches, then somehow that leads to a change in the next generation to a longer neck. And epigenetics is supposedly a bit more like this in the sense the environment is actually affecting the DNA. It's actually where it affects the DNA in a kind of way it doesn't affect the genetic code, but does change maybe where the genes switch on or off and on and the rest of it. And there's certainly interesting evidence emerging that there's a certain amount of this going on. So there's a famous example of the famine, the Dutch famine during the Second World War in Holland, where women were essentially starving to death, and that seems to have had an influence not just on the children they had, but also the grandchildren, that even though they grew up in an affluent post-war society, there's an influence. But I don't think we really know exactly how relevant this is for longer term kind of evolution in any sense. I think it's far too premature to say there's any idea that, you know, our society, our social environment has this kind of long-term effect. And you can be careful, it could be used in quite reactionary ways. It could be used to say, well, you know, because working class people are deprived of their environment's deprived, that somehow means they're sort of different genetically. I don't think there's any evidence of this at all. In fact, the best evidence that actually we can go way beyond our biology is revolutions, when people, obviously, you know, like in Egypt, people who have maybe been written off as being stupid or can only do a certain thing find incredible potential to do amazing things. So I think that's one point I wanted to make about the danger of overdoing this epigenetics thing. But one thing that is really exciting about genetics at the moment is the fact we're finding all sorts of new things out about maybe relevant to human evolution. So recently, it's been thought for a long time that 98% of the genome is junk. We've now realised that in the summer of last year, that actually this 98% of the genome may actually play some quite important roles and influence it, may be relevant to how, you know, why we're different from chimps, because it's still got to explain why 99% similarity to chimps leads to this huge difference. I mean, we're sitting in a room, electricity, chimps don't do this, do they? Not that I'm aware of it. So I think that's the exciting thing about science, is there's always new stuff to be learned, but actually we always got to come back to the material nature of it.
Hi, my name's Fred, and I want to thank you for a very informative and fascinating talk. My question is going to ask you to push a little bit of your analysis further towards the present. It seems, and based on U.S. culture, and it seems to be the same thing in England, there has emerged two different views of society. One I would call the social compact view. Whether or not you actually are a socialist, you do believe that society is a cooperative effort, should have a strong central government, and that people have responsibilities towards others. And the other view, now very prominent in the United States, and indeed they sometimes call themselves Darwinists, survival of the fittest. I got mine, Jack. If you didn't get yours, well, that's tough luck. If you're poor, well, it's probably because you had bad habits, you did drugs, you were profligate, whatever. But that is not my responsibility. And so the question is, there seems to be two divergent cultures at hand here, and the social compact and the so-called Darwinists. I would associate the people who want to shrink government to the size you can drown it in a bathtub, the people, Tea Party people, this is very prominent in the U.S. And so I just ask you to speculate on that. Thank you.
My name's Jim. Just one question, really. I read somewhere that the difference between, say, the ape and the human was that if an ape was cracking a nut, it will try a piece of wood, it will realise it won't happen, and then it will do a rock. The offspring of that ape doesn't learn by watching. So what it will do, it has to go through the same process. Where the human will see that process and can, like the offspring of a human, our ancestors, sees that process and can go and bring it further. You know, that was what I believe. So that the brain comes into place before them. You know, who knows?
Actually, there's vast amounts of evidence that animals do learn. Animals also, it's not merely primates, but cats, dogs, also animals do actually learn, and offspring learn from observing that. So I just think that's That's not true. I'd like to thank Paul for a brilliant summary, by the way. You won't get that anywhere else. One of the interesting things recently has been the rejection of the biological reductionism, of the seeking of an answer to what is human simply in biology. In fact, it's interesting, Chris String, in his most recent book, The Origins of Our Species, actually explicitly states, and quotes Stephen Jay Gould, saying, if you want to know what's distinct about it, you have to look not at... By the way, this is a guy who spent most of his life looking at bones, and was absolutely obsessed by the damn thing. Quite a lot of what Paul said is probably based on Stringer. He said, if you want to look at what's crucial to humanity, you have to look at the cultural question, not the biological one. I think in response to Dawkins, that's a very important shift in the academy. That's where we're looking. Now, I just want to raise another problem. One of the problems you have in all this, as Paul said, is the very small amount of evidence we have. And one of the bits of evidence we do have in terms of cultural activity is stone tools, because they persist, they don't rot. Human relationships actually aren't fossilised. They're not recorded, they're not saved anywhere. And I think, therefore, to figure out what it is that's critical in terms of that transition, cultural transition, is very difficult to identify. But I want to make one proposition, which won't come as any news to Paul, or people have heard me say this before. But I think if you look at what Marx and Engels say about production, they say a system of production involves taking from nature, consumption, but it is mediated by a system of distribution. Now, one way we can look for this is in societies that are pre-class societies. One way we can look for this sort of thing is in our closest relatives. Bonobos, I think, are a much better source of this biology than chimps, but we have to be scientific about this and look at both. And I'm not saying that there isn't food sharing in other species, in pre-human groups or whatever, but I think in the question of systematic rules for the distribution and exchange of food is one good place we can look for the cultural change that helps us make that transition from very nearly human to fully human. Now, no one can ever prove this, I said there's no fossil record of this sort of thing. Human relations die out when the groups of people die out with it. But I think it's something we should look at. And there is a lot of evidence beginning to develop. For example, there is now fossils of people who were had some physical disability, broken legs, where they've recovered from that, where they've clearly been supported through that later on, and therefore must have been supported for several years, and therefore must have been supported by the rest of the community through some sharing of food, some system of distribution. Now, whether that's systematic or not, it doesn't prove it's systematic, but it proves that it was existing. I think it's an interesting area to look at. I think it's certainly a good candidate, and it's certainly consistent with Marxist theory. Thank you.
Sorry, I just wanted to ask a question about the role of language and communication, because that was a really, really fascinating talk. And one of the things that was very interesting for me was the stage that Paul was talking about, where you have the thingy thumbs and whatever, the kind of complex use of tools, the development of the big brain, was also the kind of process where we become kind of complex social beings, because obviously within the natural world, the way that different species produce their food or their shelter, whatever, varies enormously, but that seems to be a kind of key development, that we become social beings. And from then on, the development really is about the way in which human beings cooperate together and organise themselves socially. But how important was communication and language? Because again, lots of species communicate, but language becomes something quite different in terms of development of human beings. I'm just wondering if people knew anything about that.
John Brown, Glasgow. And I know you didn't say this, and I'm not trying to put words into your mouth, but we cannot say that evolution is not having an effect on us today. For my sins, I've got multiple sclerosis, and I was asking the professor why it is there are so many of us have inflammatory diseases in the west of Scotland. And he said to me, we don't say this loud because it's still conjecture, but we think it's a product of industrialisation and everybody lived in slums for 200 years. And how he put it was like this: you're all the survivors of people who survived pandemics and industrialisation. So you all have super efficient immune systems, but you don't live in a world now where you're constantly challenged by pathogens and various other different things, but you still have that super efficient immune system, and it turns on itself and it gives you type 2 diabetes, heart conditions, multiple sclerosis, various other things like that, because the general consensus is that multiple sclerosis is caused by a lack of sunlight. Well, how did the Norwegians not get it, and the Eskimos don't get it, and how is there a big heavy incidence among the people of Sardinia of it, who, as far as I'm aware, probably get a great deal more sunshine than the people of Glasgow. So we are still affected by the world that we live in, not always for the best. Of course, we can effectively ameliorate that. Hopefully immigration will dilute the bad genes. But I would like to ask you one other question. One question. The Chinese Communist Party insists that Chinese and people from the Southern Orient, Han Chinese, are differently evolved from the rest of the world. They evolved directly in a separate path of development from Homo Erectus. I've heard that said by a number of people, including my father-in-law, who's an Indian, right? And they are claiming that they are directly descended from different Erectus populations. Is that argument now defunct? Because I've still heard it fairly recently.
Simon CBGB. There wasn't actually, Paul said there wasn't an answer about why we became human around 200,000 years ago. Actually, there was an answer, which led to the half the anthropologists in the SWP actually leaving the party. And this was over, we talk about, we've got Engels is right, we've got bipedalism, we've got tool use, we've got greater cooperation. We can have a Darwinian explanation about what made us human, but we look at gorillas. They say whether they've got Machiavellian intelligence, that they need to cooperate. If you look at their eyes, their black eyes, it's as if they're the mafia. You look at humans, we've got white eyes, we can see what we're doing. We're very open. We had bigger brains. What's a revolutionary answer for socialists? If you look at monkeys, apes, gorillas, they're alpha male dominated. If we're having bigger brains, how are we going to find protein to feed these bigger brains? We need a revolution, a women's revolution. What happened 20 years ago in the SWP is the argument got mixed up with the women's question. So obviously Chris Harman wrote this book dissing what Chris Knight wrote in Blood Relations, which he argued for a human revolution, a women's revolution. Obviously we had the Engels talked about the old historic defeat of the women in his book in the Neolithic Revolution, which happened 10,000 years ago. But I'd just like to ask Paul, the genetic evidence does show that in a recent hunter-gatherer conference in Liverpool, that the genetic evidence does show that 90% of human time on Earth, we were living in matrilocal communities.
Hello, I'm Diana from Holland. I missed the beginning of the meeting, so maybe you touched it in your meeting, but anyway. What I did hear from you is that you talked about the role of, we're standing upright, and then we could use our hands, and we got an opposable thumb, and we could use it to make tools. And also I think you mentioned, I didn't hear it, but I guess, that working together, so as a group of people, producing something from scratch till something is a very important factor in our evolution. Well, I'm wondering that if that's true, that working together, making something from scratch to something like a chair or whatever, or clothes, is important for our evolution. What is then the impact of the way labor is organized today? And I mean alienation. Because now we're just like, if you're working in a factory and you just put some screws, I think that's really bad for our evolution, because you said actually we don't really differ from the humans we were 10,000 years ago or even before that, but evolution is a process going on. So I guess that you could argue that the way labor is organized today is holding us back in our evolution.
Hi, my name is Dave Allen. I want to go back to the maths that you started with. This idea of evolution operating over 1 million years being an accumulation of gradual changes. Now, 1 million years in the terms you were talking about, roughly 60,000 generations. there's another view of evolution, and part of the problem with that first view of evolution is that it lends the idea to some kind of directionality in evolution. Evolution isn't directional, it's entirely random. And there is another view of evolution, which is that it occurs through things like, that's it. Sorry, I'm trying to remember that. The idea of interrupted equilibrium, where you have a steady state of affairs, like, for example, Homo erectus was around for many hundreds of thousands of years, a very successful species, and then all of a sudden, along comes modern humans. Did they evolve gradually and replace Homo erectus? No, they didn't. What happened was that they suddenly appeared in the fossil record. Now, it might have been over 10,000 years, it might have been over 100,000 years. We can't get that kind of granularity out of the fossil record, but it didn't occur gradually over millions of years. And this kind of thing can happen. The things we regard as giving us an advantage didn't necessarily give early modern humans an advantage in a Homo erectus world. It's quite possible that random mutations occur which don't confer any advantage on a population. That population exists within another population. And then there's a change. There's a change in the environment, new predators appear, the world gets drier, the world gets wetter, and all of a sudden that mutation, which conferred no advantage previously, becomes advantageous, and you get a new species develop. So it's not, as I say, it's not a directional thing, it's not a thing necessarily over millions of years. It can occur over millions of years, but it can also occur in very short spaces. Thank you.
Thank you. I'm an international student, so don't mind my language. My question would be like Darwin's theory of biology, evolutionary biology, has been used recently by some biologists like Dawkins, Professor Dawkins, and others to undermine social institution like religion. I don't like religion, so I'm not particularly concerned that why if religion go away. I don't have a problem with that, but the religion is a kind of a social evil or whatever, but it's a kind of a social institution. So is it justified to use evolutionary biology basically to undermine or to be aggressive about social institution? But there are only one particular social institution. If it is the case, then why the same scientific approach cannot be used to understand society as a whole, like the other oppressive kind of social institution we have? So why we don't have that approach to those institutions?
Charlotte, I'm in Glasgow. When Paul referred to that T-shirt that you see that allegedly describes evolution from chimpanzee to the highest order of evolution, white male, master of the universe, hedge fund manager, investment bank boss. The truth is that had that happened in that way, there wouldn't be any human species on the planet. Because way back, for the majority, and I think as Paul's indicated, the evidence is very small. There's a relatively little bone evidence from which we make these postulations. But nevertheless, I think that we can understand that if it wasn't the case that humans, or early humans, cooperated to provide the needs of life, food, shelter, water, protection from ice ages, etc., the climatic change that has happened in evolutionary time, I don't believe a human species would exist today. It had to be cooperation and the ability to communicate with each other, that after the bipedalism and the hands that are freed, the brain develops in order to survive, for that community for that group to survive, because the only way they could do so was through cooperation and labour. And that's the complete opposite of what the hedge fund manager stands for. If it had been survival of the fittest, individual in a group, we would have wiped each other out, because there wasn't going to be a way to provide for the food, for the shelter, for the water, for that community. To me, it's pretty obvious, and I think to most people when they hear an explanation like that, it would be obvious to them as well. Because those hedge fund managers wouldn't be able to do a damn thing if the people that did the work in society actually stopped doing it. But my last point is the question about the, somebody referred to women's oppression. The point that Engels made was about class society. The defeat of women is the rise of class society and the institution of the family that rose from class society. It is not evolution that has disadvantaged women, it's the rise of class society.
The last speaker in this session. I know absolutely loads of people have indicated they'd like to speak, so I do apologise.
Hi, I'm Trev. Just following on from the comrade's comment here, I had a question. Around the, you say there's no biological evolution from around 60,000 years ago. I just wondered what you thought about the work of Mithun and the archaeological records, where he posits that once we are engaged in as a societal species, that the brain develops biologically, that areas of the brain begin to work more efficiently with one another. I wonder if you were familiar with that view based on archaeological records. It was just a question that occurred to me because, you know, obviously that would posit there was a biological, and also his argument that once we began working with agriculture, that in fact it was a disadvantage initially for creating, if you like, a surplus, or not surplus, but for creating enough to sort of live, but it was paid off in advantages for social sort of needs. All right, thank you.
In the time, I'll just have to sort of almost deal with bullet points. And I would, if people want to go into lots of these discussions in detail, I would recommend people go and read lots of things. You don't need lots of specialist knowledge to read lots of the debates around this. And I think it's important, because sometimes people can be put off, unless I've got a certain level of academic training, I can't read it. It's not true. You can read all of Darwin with no academic qualifications at all, so people should read that. The stuff from Engels is perfectly readable and people can understand and engage with those debates. The book that was referred to by Chris Stringer, he's absolutely right, a lot of the view I've put in will be based upon that. Of course there are some technical details, but he argues the conclusions in a way that's completely accessible. The debates about genes, Richard Dawkins, I think, is wrong on lots of things, but actually he's a brilliant writer, explains his ideas really well. He's not a complete reactionary, by the way, he's a social democrat. You know, he did oppose the war in Iraq, he's got a sort of reformist, social democratic type view of the world. I think he's wrong on certain questions, but people should read what he says and engage with it. People like Stephen Jay Gould, Stephen Rose, anybody who's ever read any of their things will know it's fantastically accessible and not that difficult to read. So don't be intimidated from engaging with this. We can all have a view on these things and can all engage with the argument. So go and read it. Right, on some of the things. Some things, for example, there was a comrade who said that, oh, look at all the ape species, they're all alpha male dominated. Well, actually, that's not true. That's a myth that's being put forward. Let me give you, there's some research. For example, it may be true in chimpanzee societies in East Africa that there's the appearance of alpha male dominated, and then there's lots of arguments rose up, but this guarantees that the alpha male has more offspring and all that kind of stuff. Except when they studied it, what they found was that, yeah, that seems to be happening, but lots of the female chimpanzees are sneaking off into the jungle and having sex with whoever they choose. So the alpha male might think he's having more offspring. It's not quite as simple the equivalent of behind the bike shed goes on in the jungle. So these things are a bit more complicated than is often presented in some of the sort of right-wing popular accounts, which largely seek to justify, look, you've got these alpha males in chimps, so that must be something natural in our evolution. I'm not saying there's no evidence. Of course, there is alpha male things like that. But it's more complicated than that. People have to engage with the fact. But the one thing people never talk about, all of these people, is one of our closest relatives. I mentioned earlier bonobos. Our two closest genetic relatives are chimpanzees and bonobos. They're virtually identical genetically, virtually identical. They're much closer than either gorillas or anything like that. They're our closest living relatives. They live in Africa, but they're separated by the Congo River. Biologically, they have very little difference between them. Look at their social behaviour. Bonobos, they are very female dominated. It's the females who are the key thing in that society. Sex is a fundamental part, and it's largely female initiated and led. It's a key part of resolving disputes. They're very cooperative. Constant sex is a way of restoring damaged feelings and things. So, I'm not arguing that we should generalise from that either. But it should be a cautionary tale between sort of identifying, oh look, this is what happens with animals, therefore this must be something. You can find virtually identical biological species only physically separated by a very great big river, which have evolved quite completely different social ways of behaving, and crucially on the question of relations between the sexes, even in animals, are radically and diametrically opposed. And I think it's a foolish thing to do, to say, let's generalise from this, let's generalise from that. What we need is serious investigation of what actually is the case, and so on. But the bonobos case is the one that those people who talk about that never want to talk about, because it doesn't fit comfortably with the generalisation they want to make for political reasons, and we should use that. The question of again, it's actually not true that lots of species, but in particular apes, that the offspring of apes, young apes, can't learn cultural behaviour from their parents. I'll give one example. In Japan, there was a very famous study of apes that lived by the seashore. They learned how to get shellfish and things like that, and the offspring of that learned how to do that, and that became an established pattern among that subgroup of chimpanzees. And there is similar evidence from Africa that you can have subgroups of chimpanzees which have very different behaviour in terms of tool use and particular ways of behaving. So there is learned behaviour among apes. Now again, I'm not saying we should immediately generalise from that to humans, but some of these myths need to be challenged, because if you knock the myths down, then you can say, okay, let's get rid of those myths, now let's actually look at the evidence. And I think there's a lot of mythology and nonsense talk which needs to be knocked back. Somebody mentioned the argument that's sometimes used in China and other parts of the world. There was a long debate in evolution between what was labelled, the labels that were put out, the out of Africa and the multi-regional. And what that argument was, that Homo erectus, the first human species to come out of Africa, did spread across most of the world, actually not to Americas, but most of the rest of the world. And some people argued that what's happened since then is the local evolution of that original into different things. So that in China, for example, then that evolved into this. In Europe, that evolved into something else. Other people argue, no, that's not true. What you had was the evolution of a new species in Africa, and about 70,000 years ago, that began to then spread out of Africa. There's still debate about that. I would say the overwhelming evidence now, and I think most people who studied this would accept this, is that the out of Africa thesis is essentially correct. Of course, it's complicated because there'll be interbreeding and crossbreeding, all those kind of things between these species. But that the idea that you had the evolution of separate species, and that leads very easily to the idea of different racial characteristics. Now, we disagree with that politically, but what's important is the scientific evidence is that that's no longer a valid way of understanding human evolution. I think the evidence is quite clear that modern humans like us had a single origin in Africa and have spread out from the world since then. As I said before, that doesn't mean there wasn't then some degree of interbreeding between humans coming out of Africa and the pre-existing variants of Homo erectus. There is quite good evidence now that there was at least some interbreeding between humans and Neanderthals in Europe and similarly around the world. But the reasons people want to hang on, there's a question of evidence, but there's also some political reasons where, for nationalist or racial reasons, people want to hang on to the idea that there are distinct species or subgroups that evolved separately around the world. It's not based on good evidence at the moment, so I think we need to reject that. Somebody also mentioned that evolution, and there's a big debate in evolution about gradualism, if you like, and the speed that things happen. I mean, I think, this is just my personal opinion, that the kind of argument put forward by people like Stephen Jay Gould, that there is a problem with the question of speciation. That, as I said before, when you get variation, you get all sorts of variation. It doesn't tend to become established as separate species. It tends to then get reabsorbed back into the population, and that's why you have species persist stably over long periods of time. And then what you seem to get when you look at the fossil record, and I'm talking about over long periods of time, we're not talking about years or decades here, we're talking about over millions of years, you get concentrated bursts of rapid speciation. And there's discussion about how that process happens. I gave a hint at some of the debates, but people have to go away and read it, about the idea of environmental changes which we lead to parts of a population then being isolated. That then allows, over a relatively short, in geological terms, accumulation of variation to become consolidated within that subgroup and the formation of a separate species. And when you look at the fossil record, the label that's sometimes used is punctuated equilibrium. What you see is stability over a long period of time and then concentrated bursts in geological time of fairly rapid speciation under the subjective environment. I think there's a lot of evidence to support that, but that's a legitimate debate. There's also an argument, is everything that we have biologically an adaptation? You know, that we've got this, therefore it must have evolved to adapt to this. And again, there's legitimate debate about that. But again, I think there's reasonably good evidence that it's more complicated than that, that it is perfectly possible for something to be, you know, evolved and things be selected for, and then at a later stage further environmental changes mean that that then suddenly becomes an advantage when it wasn't an advantage usefully. People who know more biology will know, for example, that once you have bipedalism, the changes that leads to in your pelvis, now bipedalism could have been selected for, that does lead to certain changes to do with gestation and birth and things like that, which means that human babies, once you've got bipedalism, have to be born early, otherwise they wouldn't be physically capable of getting out because of the shape of our pelvis. And that then has further implications for what that means about child development and the defencelessness of young kids and so on. There are complicated things like that, and these are all interesting and legitimate questions which we need to be engaged with. The last couple of points. The language and communicate. There's a lot of argument because we don't have evidence. Because somebody made the point, stone tools and bones and fossils persist, but soft tools, most of the time people didn't use stone tools, they would have used wood and other things. Those persist, and above all, language, culture, what people did, it's very difficult to find any evidence of this until people start creating art and culture and so on like that. So it's not settled when human beings evolved anything like modern language, and there's a debate about that. Personally, from the evidence I've read, I think it evolved much earlier than some other people argue, that it was intimately bound up with the early stages of the emergence of, you know, modern Homo sapiens. But again, there's a debate about this. I think what's absolutely central is that I don't think it's possible to understand the process of human evolution without seeing, as I say, I'll use modern language, you know, and people refer Engels as language, I don't mind, gene, culture, evolution. If you want to talk about the dialectic between intellect and labor, it's essentially amounts to the same thing. It's the point that was made here, the combined package of, you know, human beings are actually bloody rubbish in lots of ways. We're not very good. We don't have big claws or teeth and things like that. The thing that gives us our advantage to survive isn't because we can fight off, it's because we have this ability to work together to shape our environment, to make tools and to socially cooperate. That's what allows us to survive, reproduce and prosper. We're not very good at many other things, you know, and it's that combined package of which at some stage language is essential, because once social things become important, communication, language, all of that becomes critical in terms of all that communication. Language must have been a key part of the process, but it's not settled at exactly what stage language that we would recognise in a modern sense evolved, and that's something that requires a lot more research. Let me sort of, on the question of religion, evolution evolution doesn't tell you about religion. Religion is a social construct. It's nothing to do with biology. Religion arises, I think, with the whole discussion that Marx had about, you know, where religion comes from and so on, why people have religion. It's essentially a product of social conditions and people's position within societies. It's not got very much to do with biology, and I think it's misguided to try and deal with arguments about religion by looking to human biology. Last 2 points. The question of, there was lots of discussion about, you know, does biology matter today? Well, yes, it does. We are biological beings. Our biology affects how we exist in the world, you know, and continues to do so. The question of is biology important is not the same one as is evolution driven by natural selection. Of course, biology matters, and biological factors do matter to human beings. That's a very different question from saying, are we still subject to evolution by natural selection? And I would argue very strongly no. That whatever impact biology has on lots of things to do with human society today, that's not the same process that Darwin argued about evolution by. I'll give a simple reason. For natural selection to work, it has to be the case that the reason some people survive and reproduce, and it's the reproduction that's the key thing, and pass on any characteristics to their offspring, and others don't, is because of biological adaptation to the environment. Now, it may well be that some people in the world today have an advantage in passing on their characteristics, the better survival prospects than others. Has that got anything to do with biology? Or is it everything to do with inequality, class, poverty, war, all those kind of things? Yes, it's not our biology that determines any longer whether our offspring will survive and reproduce. It's the question of the structure of society that determines that, and therefore natural selection is not operating. There are other things that do matter, but it's not natural selection, and that's the thing. On the brain, the key thing about a human brain is that it's flexible and adaptive. That's the defining characteristic of the human brain. It's to use technical biological, it's plasticity. So that's the key thing, it's the adaptive flexibility and plasticity. The human brain is a fantastic thing, and why it's such a good evolutionary advantage for us is because it allows us to be flexible and adaptive to all. Human beings are the only species which can survive everywhere in the world. Every other species has a limited range where it can survive. Human beings, our incredible flexibility and adaptability means we can survive in every corner of the world, and we are the only people who can do that, and it's because we have that flexibility, social cooperation and language which allows us to adapt and survive through cooperation in any environment at all. And even now, consider possibly we could survive on other planets where there are no bloody oxygen, because we have the capacity to build various things that allow us to do that. But it's our flexibility, the plasticity of our brains and the advantages that gives us to socially cooperate that allows us to do that. It's not fundamentally down to just biological things. So I'll stop there. But people should go and read some of these and engage with the debates.